Hi guys, welcome to week 4, part 1. This is for the week of May 4th. May the 4th be with you through May 8th. So this all of your assignments will be due on this Friday, May 8th. Okay, here is your to-do list over here. It is read and complete the introduction, copy notes, study the step-by-step, complete the assignment. 2 assignments in part 1. The first one is on volume. Second one is scientific notation. So we did both of those last week. Hopefully this will be a quick review for you. Of course, at the end of your packet, you have your multiplication table and division table if you would like to use those. That brings us to our introduction. So right here, we are looking at volume of a cone. Okay, so it says, well, make that more yellow. Well, we all know now that the formula for the volume of a cylinder is V equals base times height. And don't forget that this base right here is a circle. So you're going to have the area of the circle, which is pi r squared, okay, times height. But what about a cone? What if a cone had the same base and same height as the cylinder? If we could put the cone inside the cylinder, here's what it would look like right here. And I actually remember this from when I was in school. I think I learned this when I was a freshman in high school. And my teacher actually had a cylinder, and then he had a cone that was the same height and had the same base. And he poured 3 conefuls of water into that cylinder. So it really demonstrated this concept for me, and wish I could do it for you. If I had any of those things here at my home, I could, but I don't. So imagine it, right? So it says, what fraction of the cylinder's volume is the cone's volume? Well, to me, it looks like we divided the cylinder into 3 parts. And in fact, the cone would have exactly 1/3 of the volume of the cylinder. So formula for a cone is volume equals 1/3 base times height. And it's going to be the same thing with the base. It's going to be the area of a circle, pi r squared. Okay, so what would the volume of a cone, what would be the volume of a cone if it had the same base and height of a cylinder with the volume of 27 inches cubed? So if you said 9, you were correct, because that's going to be the 27 divided by 3. Okay, so then what about volume of a sphere? Volume of a sphere. So now let's talk about a sphere, or if you want to think about a basketball. It's not so easy to compare it to a prism, cylinder, or cone, and obviously because it's completely round. But what if we keep in mind that the area is measured in square units? So how many squares it takes to cover a surface, and volume is measured in cubic units, which is how many cubes it takes to occupy the same amount of space. Okay, so how does this help? Well, think of a prism where volume equals base times height, or volume equals length times width times height for the prism. And that's what we're showing in both of these. So how does this help? Well, the formula for the volume of a sphere is volume equals, here it is, 4/3 pi r cubed. So remember, we have that cubed always for volume. That lets us know it's a volume. So since we only have one dimension, which is the radius for a sphere, and that's going to be from the center of the sphere to the edge. And so we have that 1, not 3, like in a prism. It must be to the 3rd power. The pi makes sense since it's circular in shape. And the 4/3, you're just going to have to remember. It's one of those formulas. That's just how it is. Okay, so that's volume of a sphere. All right. Here we go. So here we have volume part 2. First one we have is for a cone. Volume equals 1/3 base times height, which remember that base is a circle, so it's 1/3 pi r squared times height, and we're going to find the exact volume, okay, here in our example. So volume equals 1/3 base times height, pi, which is the same as 1/3 pi r squared times height. Here's our different volumes. We have 3 is our radius and 4 is our height. Plug those values in here and we'll solve, and that gives us 12 pi meters cubed. And of course, you can also use your calculator and solve that out. Okay, so this next one is going to be the volume of a sphere. Here it is. Volume equals 4/3 pi r cubed. And so note that the radius is cubed. Okay, so that's where it can get confusing because up here, our radius was squared because it was only doing the surface area of the bottom of the cone because that was our base. Okay, so for this one, it needs to be cubed because we're dealing with a sphere. Okay, so example, find the volume. Here we have a radius of 3. So volume equals 4/3 pi r cubed. We'll plug in our radius of 3. That gives us volume equals 4/3 pi times 27. We can cross cancel. So 3 goes into 3 one time, and 3 goes into 27 9 times. And that leaves us with 4 times 9, which equals 36 pi meters cubed. Okay, so then if you were to solve that, here it would be. All right. Actually, I really like geometry and volume of three-dimensional objects. So bummer that we did not get to do that together in class, but that's okay. All right, so here we have our red resource folder, and I actually have mine pulled out right here from my packet. So as I'm working through the problems, I can easily just look for the formula that I want, make sure I'm doing the right one. Of course, I have it memorized, and you will have it memorized too by the time you get done with high school. Okay, so that is going to be for your reference. And brings us to our first 2 problems. And we'll switch to my favorite magenta. All right, so find the volume. Round the answer to the nearest hundredth. So that lets me know to use my calculator, and I'm going to round my answer to the nearest hundredth. Okay, so number 1, and of course these 2 are done for us, but it's a good practice, right? I always made you put this on your paper because it's good practice just to copy a correct way to do something. Okay, perfect practice makes perfect. All right, for our cone, here is our formula. Volume equals 1/3 base times height. Of course, our base is a circle, so it's going to be 1/3 pi r squared times height. Our radius is 2, and our height is 4, and so they get plugged in here and here. Solve that out, and it comes out to be 16.75 inches cubed. So don't forget your label. That cubed lets us know that it's volume. It's the amount of space that fits within the object inside. Number 2. Here we have our sphere. So our sphere, here's our formula. Volume equals 4/3 pi r cubed. 4/3, here's our pi, 3.141. And the radius is 5. So here's 5 cubed. Multiply them out, and we come up with the answer of 523.5 inches cubed. All All right, let's continue on. Number 3. So number 3, this is a cone. So I know my formula is 1/3. Oh, I want to write volume first. Sorry. All right, volume equals 1/3 base times height. And I like to just be in the practice of knowing it's pi r squared times height. And this one here equals base right here. Okay. Little scribbles there. All right, so let's plug in our values. I have a radius of 5 and a height of 10 millimeters. 1/3 times pi 5 squared times 10. And we're simply going to solve 1/3 times pi times 25 times 10 equals 1/3. Let me get my calculator. 3.141 times 25 times 10 equals 785.25. And we're going to do that times 1/3 or divided by 3. Gives me 261.75 millimeters cubed. Okay, and let's look over here to our answer key and yippee skippy. There it is. Number 4. And we have a little note here. It says, note that since the diameter is 6, the radius is 6 divided by 2, or we also know that is 3 meters. Okay, so volume equals 1/3 base, which is pi r, my radius, squared times a height of 3. There it is. Okay. I noticed something right here. Did you see it? So right here, I have 1/3, but I have times 3. So why don't we just simplify that right here? So 3 divided by 3 is 1. It's 1 up there, 1 down there. Cool. So now all we need is pi times 36. It's my trusty calculator. 36 times 3.141. The reason we're going to 3.141, it just gives us one number closer and more accurate, because of course pi just goes on forever. And I don't know, traditionally you just use 3.14. We're using 3.141. All right. Times pi times 30. Oh, I messed that one up. 3.141 times 36 equals 113. And if you'll look, 113.076. The direction said to round to our nearest hundredth. So I'm going to round that 7 to an 8. So that's a 0 right there. And our label is meters cubed. Check our answer key. There we are. We are good to go. Okay, number 5. Okay, volume equals 1/3 base times height. Plug in my values. Pi times, I'm on number 5, 1 squared times a height of 2. 1/3, 1 times 1 is 1, times pi, times 2, So now we have 2/3 pi, which equals, all I did was 2 divided by 3 times 3.141 equals 2.094, which to the nearest hundredth place would be 2.09, and my label is feet cubed. And there it is. All right, that's number 5. Number 6, so that was our 3 on cones, and now we have, I believe, 3 on a sphere. So you take a look here. Number 6 is a basketball. The volume of a sphere is 4/3 pi times a radius cubed. Okay, it's actually pretty easy. You just need to have that radius, 4/3 pi. And number 6, I really had to squint to see it, but the radius is 3, and I believe it's centimeters. Okay, so it's a little tiny one. A little super bouncy ball is what that is. So 3 cubed. Okay, so 4/3 pi. 3 cubed is the same as 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27. So times 27. Here's what's really cool here. I can simplify. 3 goes into 3 one time. 3 goes into 27 9 times. So that leaves me with 4 times 9 is 36 times pi. And I can use my calculator. 36 times 3.141 equals, we had this before. Or is that when I did my practice? Let's see here. Oh, I didn't work it out earlier. All right, so 36 is 113.08, and this is centimeters cubed. And I know it's here. There it is. All right, so same thing we had before. Different label, different shape. There we are. That's like making me question myself. 1, 2, 3, 4, 5, 6 answers. 1, 2, 3. All right. Okay, number 7. And right here we show that we have a diameter of 12 yards. And so here's our hint that radius equals diameter divided by 2. So that means we have a radius of 6. So our volume equals 4/3 pi r cubed. And of course, our r is a 6. So 4/3 pi times 6 cubed. So remember, that is 6 times 6 times 6. 6 times 6 is 36 times 6 is 216. So 4/3 times pi times 216. Let's erase some of this over here. Okay. So here's what I'm going to do. I'm going to multiply everything in the numerator. So this is like really over 1 over 1. And we're going to say the divided by 3 for when we are finished. So 4 times 3.141 times 216 equals 2,713. And then I'm going to divide that by 3. Gives me 904.608. I'm going to round that up to 0.61. And that's yards cubed. Alrighty, and there it is. There we go. Okay, one left. Number 8, and this one does not have a picture. How dare it? Let's read it. Here it is. A ball has a volume of 216 over 6 times pi cubic inches. Find the radius of the ball. Okay, so what it is telling us is our volume. So let's see here. Put that up here. Volume equals, and it gave it to us, 216 over 6 pi inches cubed, cubic inches. Okay, so I know that that is going to be what my volume is. So 216 divided by 6 times pi. And then I'm going to set that equal to what I know my formula is, which is 4/3 pi r cubed. And the question is find the radius of the ball. Okay, so that means that we are solving for r. Okay, so first thing I'm going to do is I want to simplify this fraction over here. I'm going to say 216 divided by 6. Oh, is 36, and we actually just had that in 6 cubed. So let's go 36 pi equals 4/3 pi times r cubed, and we're solving for r. So I'm just going to keep simplifying this. I'm going to go 36 times 3.141 equals 113. Let's see here. Oh, 4. Equals 4/3 pi r cubed. All right, next thing that I'm going to do is I want to get this 4/3 out of here. So I'm going to multiply each side times a reciprocal. So reciprocal is 3/4 over here times, I feel like I'm running out of room. All right, so I know that these cancel out, so that's going to leave me with pi r cubed. What does it equal over here? I'm going to take my 113.04 and I'm going to multiply that times 3. And then I'm going to divide it by 4. And that's my 3/4. And that gives me 84.78. Okay, now I need to get the r by itself, so I'm actually going to divide each side by pi. So divided by 3.14. Oh, look at that. Equals 27. Nice and neat. Equals r cubed. I'm going to take the cube root of both sides, which leaves me with 3 equals the radius, because I know that 3 times 3 times 3 equals 27. So we have a radius of 3, and yippee skippy, there it is. Did it. Okay, so there is volume of cones and spheres. Here we go. Whew. All right, so last week we really did a volume of a cylinder, so I guess this wasn't a review. It was a continuation of volume, so I misspoke there. But now we're going to look at scientific notation. That is our next assignment here for week 4, part 1. And look at this. Numbers 1 through 4 are done for us. How cool is that? So let's give it a go. Number 1. So I see 4.6 times 10 to the third plus 8.2 times 10 to the third. So last week when we did the addition in scientific notation, it already had the same power of 10. So all we had to do was add those first numbers. Well, look at here. Again, they have the same power up there to the third. And so we just need to add it so that we're going to put the like terms together. So 4.6 plus 8.72 times 10 to the third. Well, remember that this first number has to be between 1 and 10. So 13 is too big. We're going to move the decimal over one spot. And when we do that, then we put it into scientific notation. That means it's times 10 to the first. And we are going to add it over here. So that leaves us with 1.332 times 10 to the fourth. Number 2. Should we get a different color? Number 2. Okay, we have 8 times 2 times 10 to the fifth minus 4.6 times 10 to the fifth. Here it is. And easy peasy gives us 3.6 times 10 to the fifth. Number 3. 3 times 10 to the negative fifth times 6 times 10 to the negative second. So right here, with them being multiplied, I know that I'm going to add the exponents. Okay, so here we have 3 times 6. And then this is 10 to the negative fifth times 10 to the negative second. That's 18. And up here, we're going to add those together. So you add the opposite. So that's 10 to the negative seventh. You'll see that here. Well, we need to move the decimal over one place. That gives us another plus 1 and gives us an answer of 1.8 times 10 to the negative sixth. And number 4 I see is division. 1.5 times 10 to the negative eighth divided by 6 times 10 to the seventh. Copy very well. Okay, so when we do this, look, we can put like terms together, and we're going to subtract the exponents. Okay, so, and of course, add the opposite as you see here. And this one here, we had to move the decimal place over, which gives us another minus 1. So we have these two together is the negative 15 plus another negative 1. Our answer is 2.5 times 10 to the negative 16th. Okay, so now here is our turn. There we go. Okay, and I am actually, my answer key here, come on. Yeah, I'm gonna raise that up, hidden behind my head there. All right, we are set. Number 5. All right, so we have an addition problem. And it is 2 times 10 to the fifth plus 3.8 times 10 to the fifth. Look at easy addition because the powers of 10 are the same. So that is good news. So all I'm going to do is add 2 plus 3.8, and it's going to be times, that's a times 10 to the 5th. 2 plus 3.8 is 5.8 times 10 to the 5th. There is our answer. Check over here, and there we go. Number 6, subtraction problem, 9.2 times 10 to the 8th minus 4 times 10 to the 8th. Yay, same power of 10. So we're just going to go 9.2 minus 4. And that is times, we put in parentheses if we want, times 10 to the 8th. 9.2 take away 4 is 5.2 times 10 to the 8th. Check our answer key. There it is. Good. Okay, number 7. 2 times 10 squared times 3 times 10 to the negative 5th. So I know when I'm multiplying in scientific notation that I'm going to add the exponents. So let's combine our like terms. So that will give us 2 times 3 times 10 to the 2 plus negative 5. Okay, so we're going to add the exponents. So 6 times 10, and we say 2 plus negative 5 is going to be negative 3. There it is at the top. Good. Okay. Oh, whoops. Erase. Number 8. 5.8 times 10 to the negative 6th divided by 2 times 10 to the negative 3rd. Okay, so let's put these into fractions, which will show our division. So 5.8 divided by 2 times 10 to the negative 6th divided by 10 to the negative 3rd. Okay, so 5.8 divided by 2 equals 2.9 times 10 to the negative 6th minus negative 3. Okay, so we have 2 negatives here. 2 negatives make a positive. So that gives us an answer of 2.9 times 10 to the negative 3rd. And there it is. Okay. Moving on. Number 9. Okay, 5 times 10 to the negative 5th plus 2.46 times 10 to the negative 5th. And same power, so I'm going to say 5 plus 2.46 is 7.46 times 10 to the negative 5th. Guess I skipped a step, but we could do that one mentally. And here it is. All right. Number 10. Okay, 6.33 times 10 to the negative 9 minus 4.5 times 10 to the negative 9th. Same power of 10, so we have 6.33 minus 4.5 times 10 to the negative 9th. 6.33 minus 4.5 equals 1.83 times 10 to the negative 9th. There it is. We are good. Okay, 2 more. Number 11. All right. 6.5 times 10 to the 8th times 2 times 10 to the negative 5th. It's 5 and a negative. All right. So we're going to multiply 6.5 times 2 times, and remember we add the exponents, 10 to the 8th plus negative 5. Okay, so 6.5 times 2 is 13. Kind of confusing there. 13 times 10, and so 8 plus a negative 5 is 10 to the 3rd. However, look at this is greater than 10, so know that that's 13.0. So I need to move my decimal over. And when I do that, that's another 10 to the 1st. So I'm simply going to add 1 right there. Okay, so that's going to give me 10.3 times 10 to the 4th. And there it is. Yay, we did it right. Okay, number 11. Last one. Number 12. Division 3.6 times 10 to the 7th divided by 7.2 times 10 to the 7th. Same power of 10. What will happen? So here we go. 3.6 divided by 7.2. So then we have 10 to the 7th divided by 10 to the 7th. Okay, so right here, well, here, let's work this out. 3.6 divided by 7.2 equals 0.5. And then look at this. So times, so looking at this, 10 to the 7th divided by 10 to the 7th obviously is 1. The other way, if you're doing it with our scientific notation, it would be 10 to the 7th minus 7. So let's show that. 10 to the 7th minus 7, which is going to be 0.5 times 10 to the 0. Okay, but here's what I want to do. So easily that could be 1, right? We know that any number to the power of 0 is 1. But we have this decimal right here. There it is. And we need to move it this way. And we're going from a small number to a bigger number. So that means we are going to subtract 1 up here. Okay, so now that leaves us with 5 times 10 to the negative 1. And there it is. Okay, We got it. So great job. I hope that you guys are doing well on this. I got a lot of feedback last week that you guys felt pretty confident with volume of a cylinder and scientific notation. So hopefully this first assignment was just like that, because the second one is a review for your benchmark number 7. It's a doozy. So we'll do that one next. Okay, so as you start your week on this May 4th, may the 4th be with you. Remember who you are, remember what you stand for, and lead by example. See you soon. Bye-bye.